What we are going to see in this video is the engineering design process we use in our curriculum, starting with the design and coding a digital prototype, and then progressing to build and coding the physical prototype. This foundation in a problem-based learn approach teaches students the essential skills to innovate and solve real-world problems. Today we are working with a digital design for building a video game. So the first thing is going to be going to circuits and create a new one. And as soon as we are ready, the next step is going to be changing the name of our project. In here we are going to LCD video game. We are going to give a name. Today we are working with an Arduino Uno with an LCD. We need a resistor and 2 push buttons. So we are going to start with a microcontroller. In this case, we are going to use Arduino Uno. So we are bringing Arduino to the top of our screen. For the wiring, there is a breadboard here that we will need, a small one. So we are bringing the breadboard in here. We will need our LCD, 16-2 character. So see, this one is 16 characters, 2 rows, and a resistor for controlling the brightness and energy of our LCD. So as soon as we have all the components, we can close this section. So we will have space for the wiring. If the components do not fit on the screen, so we have an option at the left for zooming to fit. So we can click, and we have already enough space for building a project. So so let's bring the push buttons to. We have the 2 push buttons. So that way we complete the whole project. Next thing is going to be placing the LCD on the breadboard, just making sure that the pins of the LCD are connected to the pins of the breadboard. We need as well 2 push buttons placed on the breadboard, and these are going to be connected between the pins between the bridge, which is this one. We are leaving the resistor here for later. Now, this is what we need for starting the wiring. Next thing, we need to look for the 5 volts and ground, and those are going to be connected to the rails of the breadboard. We have 1 rail for ground, which is the blue, and 1 connection for 5 volts or the positive side of the breadboard. So in here we are going to look for 5 volts, and this one goes to the red section or the positive, and in here we change to red. That way we can identify that we have 5 volts. The next one is our ground, and this one is going to be connected to the blue section of the breadboard, and that way we have 5 volts and ground ready for other connections in our breadboard. So we are going to start with the first push button. It has 2 connections here. The left one usually goes to ground, so we are going to connect this one to ground, changing to blue, so we will identify that we are working with the negative side. The next pin goes to the Arduino Uno. In this case, this connection is going to the digital number 2. So we are going to look for the digital number 2, which is in here. We click. We can leave the color in green color. Now in here, we have, by clicking on the cable, we can change the position of our cable. We can bend it, so like this. So that way we can make space for other connections or to see the wires better. So like that. Second push button has the same, one connection to ground. And in here, this one goes to blue. The second pin is gonna be our Arduino Uno, and this one is gonna be the connection number 1 or digital 1. Changing this color, so we will identify the connections. Clicking for bending the cables. So we will identify the connections. Our next component, the last one, is the LCD. LCD has 16 connections, and we are gonna start with left to right with the first one, which is ground. Ground is, we are going to use all the rails of our breadboard, and the pins can be connected either way on the LCD or on one of these pins. So I'm gonna start with this one. I will do the wiring from here and then going all the way to ground. Let's change to blue, indicating that we are working with negative or cathode. Our next pin is power. Power goes to 5 volts, so all the way to the positive or red section of the breadboard. Our third connection is the contrast, and this one is going to be connected to the number 12. So in here, we are going to draw a cable all the way to the number 12, digital 12. So that way we have a connection to the number 12. The next one, which is the register and select, goes to the number 11. So we are going to look for the number 11, digital 11, and we click on it. So that way we have a second connection. Next one is writing. So in here we are going to connect to number 10. Following by enable, and enable goes to the number 9. Like that. So for seeing better these cables, we can actually change them to one of those rails, and that way we can see the connections better, like that. Now I'm gonna start from right to left because I need to test if the LCD has brightness. So if I start with the number 16, which is the cathode, this one is indicating that the connection goes to ground. The second connection is the anode or the positive power. In here, we have to be very careful. We need a resistor, and we already have it here. So this resistor can go straight into the positive side. And there is something else we need to do here. Since this one is 1 kilo ohm, is not going to work. We need to change this value to 220 ohms. So that way we will have enough protection for our LCD. Then the third connection, which is the reading of data. This one is going to be connected to the number digital 3 of our microcontroller. So we are going to look for the digital 3 and we connect. We're going to use another color to identify the connection. The second one is another digital. This digital goes to the number 4. Another digital that goes to number 5. And here we have the last one for reading data. And this one is gonna be digital 6. Goes to, let's see, let's look for another color. Purple. There. So that way we have our wires ready. We can check the simulation, start the simulation, and to see if our LCD has brightness, which has. You could see here that there is a little bit of brightness. So our project is ready for the second and last step, which is the code. In this section, we are going to use code. By clicking in here, we are going to look for the select. We're going to select text, since we are going to use C++. So text, we will continue. And we need to erase this code that Tinkercad is providing, because in here we are going to start typing our own code. So the last part of this project is going to be the typing of the code. Since we are using an LCD, we need a library. So this is the first thing we're going to include. It's going to be a liquid crystal. Usually libraries end in .h. So we already have it, line number 1. And then we're going to start declaring all the variables. So those are going to be defines. So the first one is our pin button. And this one is connected to our pin number 2. Another define that we have here is the pin for the autoplay. This one is going to be our number 1. Another define for reading and writing data. So it can be read, write. This one is connected to the number 10 of our Arduino. Then the define for contrast. So we need pin contrast. And this is our number 12. So the way we have our variables. Our line number 6 is basically the function of our video game. So we need to define as well the running. So we are going to use a sprite run, which is going to be the number 1. Another define for sprite run number 2. Defining the sprite, and this one is for jumping. and pin number 3. So we are going to continue with the next section of code. So as soon as we have our code complete, the next thing is going to be testing the prototype. So in here, we can use the zoom to fit, and we will have our project next to the code, so we can start the simulation to see if we have some mistakes in the code or if the project is working correctly. We're going to start the simulation, and we have here our the first part of the game. So we are going to click to start the video game. So in here we will have our project working. So for building the engineering prototype, we are going to use cables. Of course, the USB cable for programming our project in Arduino IDE. We will use as well 2 push buttons, one 220 ohms resistor. In here we have the LCD, a small breadboard, and our microcontroller. So these are going to be the components that we are going to be using. So the first thing, I'm going to start with the wiring of the breadboard and the microcontroller. So in here, we need to look for the 5 volts as we mentioned in Tinkercad. So 5 volts is going to be located right here in this section. So we are going to connect 5 volts to one of the pins on the positive side of the breadboard. So we are going to connect in here. So that way we have 5 volts. We will need ground. So usually ground is next to. So the next thing is going to be the connection of ground, like this, to ground of the breadboard. So that way we have the 2 connections ready. Let's see. Going to move these ones a little bit to the right, so we will have space for the LCD. The next one is going to be our LCD. Our LCD, I will place it here, so I will have enough space for the push buttons. So just making sure that the pins of the LCD are connected to the pins of the breadboard, like that. That way we have the LCD connected. So next, the connection of our 2 push buttons. So we are going to place one here, can be in here for the connections, or we can put it here between the bridge, which is going to be easier to connect. 1 and 2nd, like that. So we already have our 2 push buttons connected. So we are going to start connecting the first push button, and this one, the left leg, goes to ground. The second one is going to be connected to the Arduino microcontroller. In this case, we are connecting this one to the number 2 in here. All right, number 2 of the microcontroller. Our second push button is going to be the same to ground. Second pin goes to number 1 of the microcontroller, which is going to be number 1. So that way we have the first 2 push buttons connected. Next is going to be the connection of our LCD. So in here we will need ground, which is going to be the first connection. So in here we are going to place in section number 1 ground. Which is this cable to ground from here to here. Second connection, which is this one, goes to 5 volts. 5 volts, like this. Number 3 goes to the number 12 of our microcontroller, which is here, 12. So far we can see the connections. So this one is our number 12. We have the number 4, which is this one. Let's see. This is going to be to number 11, and this one is the 11 that we have next to this connection right here. Goes to the number 10, which is in here. So we have a row of cables already here, so which is 12, 11, and 10. Then we have cable number 6 connected to the microcontroller, and this one is gonna be connected to the number 10. Sorry, number 9. So we have 9, 10, 11, and 12 connected. Let's see, we can take a look to the connections. Okay. I'm gonna start connecting this section of our microcontroller, which is this one, and I'm gonna start with the number 16, which is ground. In here I need a cable on number 16 and this one is going to be connected to ground of the breadboard. There is a second connection, which is 5 volts, and in here we are going to connect this one passing the bridge like this, because in here we need to add the 220 ohms resistor, which is this one. So in here we connect the cable to 5 volts, and this one can be like this. Connected to one of the rails of 5 volts. The next connections that we have in here are the reading of data of our LCD. So we are gonna start with this one, the third one. This is our connection that goes to number 3. So we're gonna start connecting this one to number 3 of the microcontroller, which is in this section. Number 4, which is this one, is gonna be to number 4 of the microcontroller. Number 5, which is in here, goes to number 5 of the microcontroller. There. And there is the last cable for reading data in our LCD. This one goes to number 6 of our microcontroller. So that way we have all our cables connected. So this one is the prototype finished. We can take a look to the prototype, just making sure that we have all the connections. So like this. The next step here, and the last one, is gonna be the programming. There is a connection in our microcontroller, which is this one, and in here we are going to add the USB cable. This USB cable is for programming using Arduino IDE. So I'm going to connect this one to my computer. So we will see that our LCD Now we will see the LCD turn on. After that, we are going to upload the code to our microcontroller. We are opening Arduino IDE, and then in here we open a new project, erasing what is in here and pasting the code that we had in Tinkercad. So like that. That way we have our code ready. The next thing is giving a name to our project. So in this case, it's gonna be LCD video game. We save the document, and then we wait until this information is processed. And our next thing is finding the microcontroller and the port on the tool icon. So in here we are going to look for Arduino Uno, which is already here. Since we have our project connected, so we're going to click on Arduino Uno, and then the next thing, looking for a port. So the port is already here. When it's not here, we look just in serial ports, and the program will find it. So we click on this one. The next thing is gonna be compiling the project. So this is gonna be the next instruction and the last one. As soon as we have this, we compile. The information is gonna be passed to the microcontroller, and in here we will see the process. When it finishes, it displays information here in white, meaning that the uploading, the compiling was a success. So this one is the project finished. The Arduino IDE uploaded the code to the microcontroller, so you will see the project on the LCD. Now, if the LCD is too bright, there is a way to control that. We have the connection of our microcontroller to 5 volts, so it's just to change the pin from 5 volts to 3.3, and the brightness is gonna be less. These two buttons are gonna be for controlling the video game. So in here we can use the first one, and it's gonna be for starting the game. So the little guy is gonna be jumping, and in here this one is for starting a new game. So like that. So basically that is all the project. In here the idea is the guy has to jump as many obstacles as possible. So thanks for watching.